Find the total displacement of a body in 8 seconds starting from rest with an acceleration of 20 centimeter per second square. Okay, so this is a very straightforward question. So let us first write down the given details. See, since the body starts from rest, we can say that the initial velocity u is equal to 0. Acceleration is given as 20 centimeter per second square. 20 centimeter per second square. And we've been asked to find out the displacement of the body. Okay, so let's first write down the displacement time relation, which is given by S is equal to ut plus half at square. See, I do understand that students who are focusing especially for the MCQ exams, these kind of steps may sound very basic to you, but as I've discussed in the previous questions also, that the initial questions will be discussed in much detail, and when it becomes relevant that we need to improve the speed, we will definitely do that even while solving the questions. So those students who are more familiarized with the kind of questions, please feel free to skip these videos and go to the next higher set of problems. Okay, so for freshers, let's start solving this question. So we have S is equal to u is 0, so that terms becomes 0 plus half a. What is the value of a? Is 20 centimeter per second square into what is t? T is given as 8 seconds, so that becomes 8 into 8, 64. So 2 and 20 will get cancelled, we get 10. So basically the answer becomes S is equal to 640 centimeters. An object accelerates from rest with velocity and attains velocity 27.5 meter per second in 10 seconds. Then find the distance covered in the next 10 seconds. Okay, let us try to first visualize this question and then we'll try to answer the question. See, what's given is, say for example, from A to C with intermediate B, say A to B is 10 seconds and from B to C the time interval is 10 seconds. Now, if we consider the motion for the time interval AB, mind you, AB is not the distance moved, it's the time interval. So, for the time interval AB, what can we write the equation of motion as? V is equal to U plus AT. What is V? It is given that the body has attained 27.5 meter per second. What is U? U here is 0. Why? Because it's given the question that it is from rest. So that becomes 0 plus A into T. How many seconds is the interval? It is 10 seconds. Which means, what is the value of acceleration? Acceleration is 27.5 meter per second per 10 second, which is basically 2.75 meter per second square. Now, we should understand that the body at this point has an acceleration, or for that matter, body throughout the motion has an acceleration of 2.75 meter per second square. But for the time interval BC, the velocity of the body here becomes 27.5 meter per second, right? Why? Because at this point B, the question says that the velocity is 27.5 meter per second. In which case, what would be the displacement time relation? It would be S is equal to ut plus half a t square. What is u? U is 27.5 meter per second into what is time. Now, the next time interval for BC is again 10 seconds, so that becomes into 10 plus half into what is acceleration? Acceleration is 2.75, and what is t square is 10 square. So this basically becomes 270. So it becomes 275 plus. So 2.75 into 10 square becomes 2.75 into 100 by 2. This further becomes 275 plus 275 by 2. right? So this can be calculated as 275 by 2 is 2 times 1 is 2, 3 2s are 6, 15, 7 2s are 14. So we can have is 137.5. So this becomes 275 plus 137.5. So 275 plus 137.5 gives you 7 5s are 12, 7 1s are 7, 7 plus 1 8 plus 3 11, 2 plus 1 4, 412.5 meters. So the correct option is option C. A point initially at rest moves along the x-axis. Its acceleration varies with time. A is equal to 5t plus 6 meter per second square. If it starts from the origin, distance covered by it in 2 seconds is. Okay. So this is a straightforward application of differentiation or integration. Let's see how to solve this question. So what's given here is the acceleration time relationship. So it goes like this. So what we given is A is equal to 5t plus 6. Now what is A? Acceleration is rate of change of velocity d by dt of v is 5t plus 6. In which case, what is v? Will be the integral of 5t plus 6. So let's write like this. dv is equal to 5t plus 6 dt. Now, what is v? Will be the integral. Okay, I think I made a small mistake here. Let's not skip the steps. Okay, so dv is equal to 5t plus 6 dt. Now integrating on both sides, what do we get? V is equal to 5 into integral of t is t square by 2 plus 6 into integral of 1 is t, right? 60. Now if v is equal to 5t square by 2 plus 6t, what is v? V is dx by dt, which is further equal to 5t square by t plus 6t. What is dx equal to then? Dx will be equal to 5t square by 2 plus 6t dt. In which case, what is x? We can integrate it on both sides, and what do we get? What we get is 5 by 2 into t cube by 3 plus 6 into t square by 2, right? Now, what are we asked to find out? See, since it starts from the origin, the lower limit is 0, so we just need to find out the higher limit, upper limit, which basically here is 2 seconds. So x at t is equal to 2 seconds would be 5 by 2 into 2 cube by 3 plus 6 into 2 square by 2, which basically is equal to 5 by 2 into 8 by 3 plus 6 into 4 by 2, which is further equal to 40 by 6 plus 12, which is equal to 40 plus 72 by 6, which is equal to 112 by 6. So now we divide 112 by 6. 6 ones are 6, you get 42. 6 eights are 6. We have 52. We have 6 eights are 48. What left is 40. 6 6 are 36. So the only option which starts with 1 and 8, 18 is option A. Particle experience a constant acceleration for 20 seconds after starting from its minor mistake here, it's rest. Travels a distance s1 in the first 10 seconds and distance s2 in the next 10 seconds. Then, so basically we've been asked to find out the relationship between s1 and s2. Okay, so let's try to understand the question by drawing a rough illustration here. So let us say the particle was moving from A to C or A to B at intervals AC and for distance AC and CB, the respective intervals were 10 seconds and 10 seconds. Now a particle experiences a constant acceleration for 20 seconds. Okay, so the whole time period here is 20 seconds. Okay, so let us see for the time interval AC. For the time interval AC, what can we write the displacement time relationship as? It can be written as S is equal to ut plus half a t squared. Now, since the body starts from rest, we can say that initial velocity is equal to 0, which means that S is equal to half a t squared. Or let us use S1 here and S2 as given in the question. So this is S1 is equal to half a t squared. What is t? T is 10 seconds, right? Which means S1 is equal to half into a into 10 square, which is basically a into 100 by 2, which is 50a. Now, what is the next interval? See, if you take the next interval as S2, we don't have the terms to find the, or we don't have the value of the terms to find the correct equation. So what we'll do is we'll take the complete length. The complete length will imply that the whole length or the whole distance S1 plus S2 is now equal to, again, ut plus half a t square. Since the body starts from rest, ut becomes 0. So what do we get here? Half into a into, what is t? T is now 10 plus 10, the whole square. So this becomes 20 whole square a by 2, right? Okay, so let me just write down this equation once again. So we have S1 plus S2 is equal to 20 square is 400, 400 by 2 is 200, so we have 200a. Now what is S1? S1 is 50a. So let us write down over here. So we have 50a plus S2 is equal to 200a, which means S2 is equal to 200 minus 50, which is 150a. Now let us try to express 150a in terms of 50a. So this can be written as 3 into 50a. Again, what is 50a? 50a is nothing but S1, which means S2 can be written as 3 into S1, which makes the correct answer as option C. An object starts from rest with an acceleration of 2 meter per second. No, this is not 2 meter per second square. After 5 seconds, the direction of acceleration reverses again for 5 seconds. Then the new displacement is. This is a really good question. I'll just give the diagrammatic representation first and then we'll solve it. See, let us say the object is moving from A to C through B. So at this point, the initial velocity is equal to 0 and the object is moving with an acceleration of plus 2 meter per second square. After 5 seconds, which means it has traveled for 5 seconds, the direction of acceleration reverses. Mind you, the direction of acceleration reverses and not the direction of motion, which means the body is still moving in the same direction, but acceleration here becomes minus 2 meter per second square. Or in other words, this much region was the region where the body was under acceleration and now the body has started decelerating, right? Okay, now let us say displacement is AB in first case and displacement is BC in the next case. Okay, and let us call that as say x1 and x2. Now for the motion along AB, what is given? U is equal to 0, A is equal to 2 meter per second square, time is equal to 5 seconds, and we have x1. Okay, now for this motion, what is displacement time relation? S is equal to ut plus half a t square. U is 0, therefore this term gets eliminated. S here is x1, so x1 is equal to half into acceleration is 2 and time is 5, so this 5 square. So basically what we get is x1 is equal to 25. And since all the units are in meter, acceleration is also in meter per second square, so this x1 is 25 meter. Now what happens is, along AB, we know that V is equal to U plus AT, right? V is equal to, U is 0 because the body starts from rest. What is A? A is 2, and what is T? T is 5 seconds, which means V is equal to 10 meter per second. Now what is the significance of this velocity? This velocity means that the velocity is for the movement of body along BC. The initial velocity is velocity at B, which is VB, what we just found out as 10 meter per second. Now, what is the time taken? The time taken is given that it is again for 5 seconds. So this much time T2 is basically for 5 seconds. And acceleration is given as minus 2 meter per second square. Now, what we need to understand is, since we are finding out BC, which is basically x2, we can directly apply the formula, which is S is equal to ut plus half a t square. What is S? S is x2. What is u? It is t. So this is 10 into, what is t? T is 5. 5 plus half into, a is not 2, it is minus 2 times t square is 5 square. So x2 becomes 10 into 5 is 50. 2 and 2 will cancel off. So 2 square minus 20, 50 minus 25, which is basically 25. Now, the new displacement is being asked in the question, right? So we can say that the new displacement is basically AC, which is equal to AB plus BC, which is equal to 25. Or to be more precise, is basically x1 plus x2, which is nothing but 25 plus 25, which is 50 meters. So the correct option here is option B. When a bullet is fired at a target, its velocity decreases by half after penetrating 30 centimeter into it. The additional thickness it is not time, it is travel before coming to rest is. Okay, so this is a very good question. Let us first try to visualize this and then we'll try to answer the question. See, say for example, this was the bullet when it left the gun, right? So when the bullet is leaving the gun, it will definitely leave with the velocity u. When it enters a target, say this is the target. So this is the target. Now when it enters the target, it will enter the target with velocity u, right? According to the question, it decreases by half after penetrating 30 centimeter. So let us say this much distance is 30 centimeters. Which means the bullet will slowly come through this region, and when it comes to 30 centimeter, its velocity will become half, which means at this point the velocity is u by 2. Let me just translate this. So this is A and this portion is B, which means for the journey AB, the initial velocity is u and the final velocity is u by 2, and the distance traveled is 30 centimeters, right? In which case, if we apply v square minus u square is equal to 2as, what is v? V is u by 2 the whole square. What is a? What is u? U is u itself, so this becomes u square into 2 into a into what is s? S is given as 30 centimeters, right? Now, if you solve this algebraically, what do you get? You get u square by 4 minus u square is equal to 60a, which further means minus 3u square by 4 is equal to 60a, which basically means that a is equal to 60 into, sorry, a is equal to minus 3 by 4 into u square by 60, which is a is equal to u square minus u square by 3 times 60 is 20, so you get a square u square by minus 80. Now, which means that the deceleration faced by the body here is basically a is equal to, sorry, deceleration is u square by 80, or otherwise the acceleration is minus u square by 80. Now, is the question done? No. Why? Because we've been said that the additional thickness before coming to rest, which means the bullet here will slowly travel some more distance and at some time will come to rest, which means at this point the velocities will become 0. And let me mark that point as C. And if we draw the path BC now, if we draw the path BC, we don't know the distance traveled. The distance traveled would be s, but what we know is the velocity here is going to be equal to 0, which means the final velocity is going to be equal to 0. And what is the acceleration? The acceleration is minus u square upon 80. Which means if we apply the equation here, v square minus u square is equal to 2as. What is v square? V square is 0. What is u square? U square is u by 2. So what we get is minus u by 2 the whole square is equal to 2 into a into s. So this is minus u square by 4 is equal to 2 into a. What is a? A is minus u square by 80 into s, which means u square and u square will cancel, negative will cancel off. What we get is 2 by 80 is 40, 4 by 40 is 10, so s is equal to 10 is what we get. And you may think, why did I not change the dimensions from, sorry, the unit from centimeter to meter? Because all the options were basically in centimeter, so that is why I used only centimeter here. So the answer here is 10 centimeter, which means the correct option is option C. Starting from rest, a body travels for 30 seconds with constant acceleration. It covers the distance s1 during the first 10 seconds and distance s2 during the next 20 seconds. The value of s2 will be equal to, we did a similar question a couple of questions back, so let's try to understand this also. So we have a body starting from A, moving till C through the intermediate position B. Let us say the time taken from A to B was t1 and time taken from B to C was t2. According to the question, t1 is 10 seconds and t2 is 20 seconds. Also, it's given that the displacement during the first time interval is s1 and the displacement during the second time interval is s2. Now, if we analyze the path, we can say that for the time interval, for the time interval of 10 seconds, we can say that s is equal to u, or rather s1 is equal to ut plus half a t square, or rather ut1 plus half a t1 square. But we know that the velocity at a is equal to 0 because the body is beginning from rest. So this term will get eliminated. So what do we get? S1 is equal to half into a into what is t1? T1 is 10 square. 10 square is 100. 100 by 2 is 50. So this is 50a. Now, for the next interval, say for example, we have for the time interval of not 20 seconds, we're going to take the whole time interval, which is 10 plus 20, 30 seconds. We can say that not S2 again is S1 plus S2, which means we are basically covering the whole journey from A to C, is equal to, again ut would, that term will become 0. What we have is plus half A into T1 plus T2, that is 10 plus 20 the whole square, which is equal to 10 plus 20 is 30, 30 square is 900, 900 by 2 is 450A. So we can say that S1 plus S2 is equal to 450A. But what is the value of S1? The value of S1 is 50A, in which case this becomes 50A plus S2 is equal to 450A, which means S2 is equal to 450 minus 50 is 400A. In terms of S1, I can write S2 as S2 is equal to 8 into 50A, right? Now, 50A is basically S1, so this becomes S2 is equal to 8 into S1. So the relation that we get is S2 is equal to 8S1, which marks the correct option as option C. A body moving with uniform acceleration describes 20 meter in second and 30 meter in fourth second. Calculate the distance covered by it in 6 seconds. Okay. So this question basically makes use of the formula Sn, which is basically displacement in the nth second. Sn is equal to u plus a by 2 into 2n minus 1. So the question says that it covers 20 meter in second, which means 20 is equal to u plus a by 2 into 2 into second. So n is 2 minus 1. And 30 meter in it fourth second, which means 30 is equal to u plus a by 2 into fourth second it is. So it is 2 into 4 minus 1. Okay. So this basically becomes 20 is equal to u plus 2 into 2 is 4, 4 minus 1 is 3, plus 3a by 2, and this becomes 30 is equal to u plus 4 into 2 is 8, 8 minus 1 is 7, plus 7a by 2. So let me mark this as equation number 1. This is equation number 2. If I take the denominator, if I take 2 on to the LHS, what we get is 40 is equal to 2u plus 3a, and from equation 2, cross multiplying 2, we get 60 is equal to 2u plus 7a. Now if you subtract these two equations, or if you subtract 1 from 2, what we get is 20 is equal to 4a, which means a is equal to 5 meter per second square. Now if a is equal to 5 meter per second square, 40 will be equal to 2u plus 5 into 3 is 15, which means u will be equal to 40 minus 15, that is 25 by 2, which is 12.5. Okay, 12.5 meter per second. So we got two values now. One is a is equal to 5 meter per second, and then u is equal to 12.5 meter per second. Now, is this what we've been asked to find out? No, we have been asked to find out the value of S6 second, right? So we have to ask to find out the value of S6. So what is S6 equal to? S6 is equal to u plus a by 2 into 2 into 6 minus 1, which means S6 is equal to, what is u? U is 12.5. 12.5 plus, what is a by 2? A by 2 is 5 by 2 into 2 into 6 minus 1, which is equal to 12.5 plus 5 by 2 into 11, that is 12.5 plus 55 by 2, which is further equal to 12.5 plus 55 by 2 is 27.5. 27 plus 12 is 39.5 plus 0.5 is 1. So 39 plus 1 is 40. So the correct option is option D, 40 meters. A body is moving with uniform acceleration of 10 meter per second square. If its initial velocity is 0, calculate the displacement after 5 seconds. See, ideally this question should have come up in the first or the second serial number, but somehow it came to the question number 9. Apologies for that. Right, so very straightforward question. We've been asked to find out the displacement. So displacement S is equal to ut plus half a t square. The initial velocity is 0, which means this term gets cancelled, so we get S is equal to half a t square. Acceleration is given as 10 meter per second square, so this is 10 into time is given after 5 seconds. After 5 seconds, let us check the unit once again. Meter per second square, 5 seconds, right? So this is 5 square. What do you get? So S is equal to 5 square is 25. 25 into 10 is 25. 25 is 250. 250 by 2, which basically gives the answer as 125. So the correct option is option C. So this again is a very simple question. When I say simple, I mean level 1 questions, belonging to level 1 questions, but somehow it just appeared in the last section of the video. Okay, no issues. Let's start solving it, and then let's see high level questions in the next topic. Okay, so a body starts from rest and acquires a velocity of 12 meter per second in 5 seconds, which means V is equal to U plus 80. Starts from rest, so U is 0, which means V is equal to 80. Attains 12 meter per second in 5 seconds. 12 is equal to A into 5, which means A is equal to 12 by 5, which is 12 by 5 is 5 to 10, 22.4 meter per second square. So the acceleration is 12.4 meter per second square, and the distance moved by the body is S is equal to ut plus half at square. Again, ut disappears. What we have is equal to half. What is the value of A? A is 2.4. What is the time? Time is 5 seconds, so this becomes 5 square. So basically what we have is 1.2 into 25. So this is basically, how can you right now make it calculation simple? It would be 25 into 1 plus 25 into, okay, that doesn't make sense. Let's do the calculation directly. So 25 into 12 is 25 into 10 is 250, right? Plus 25 into 2 is 50. 250 plus 50 is 300. 1 decimal point 30. So the correct option is option C, 30 meters.